So I'm happy to introduce Julie, who is on the East Coast. Oh my God, I forgot where. Julie, tell me where you are.
North Carolina.
She's in North Carolina. Because everything east of the Mississippi is just a big mush to us here in Tucson. It's terrible, but true. She is a friend of Sabrina's. I think most of you know Sabrina. And I'm going to read you why we are really interested in what she has to say. She joined the Goodson Law Library as a research services librarian and senior lecturing fellow in 2022 after receiving her MSLS from the University of North Carolina at Chapel Hill. In addition to providing research services, Julie teaches in the legal analysis, research and writing program, and an advanced legal research course, AI in legal research. And there's a whole nother paragraph, and I won't say that right now, but I'll say that how happy we are to have her. And she is not going to teach us the same thing that she teaches people that are in graduate school. And for that, we say thank you. We're very grateful that she's going to tell us what it is that what she thinks that we want to know, and then we'll ask questions if it's anything other than that. And I think this is where I'm going to be quiet, and I am going to spotlight Julie and let the knowledge flow.
Wonderful. Thank you, everyone, for joining me here today, and thank you for inviting me to talk to you about AI. Before I get started, I do want to say while I am an employee of Duke and the J. Michael Goodson Law Library, any views or opinions expressed are my own, and they do not represent my employers in any way. So I'm going to start. There'll be 3 parts to my kind of presentation, and I'll stop after each part to get questions and kind of sum up any issues or anything I might have left out that you're curious about regarding those topics. The first part, I'm going to explain AI and what it's doing behind the scenes. Then we're going to talk about prompting. I'll give you some tips on how to get what you want out of it. And then we'll go into when you should use it, when you shouldn't, and then some of the common issues with it, the environmental concerns, costs, things like that. I'm going to go ahead and share my screen. So ChatGPT, a peek inside the black box. So much of the confusion around AI is really because the terms used to describe it don't make a lot of sense, and they can be really counterintuitive. So I'm going to start by breaking down some of the terms that you may have heard used to describe AI and what they really mean. So let's get started with the big one, AI, artificial intelligence. The very name of it is misleading and part of the big problems with it. So while AI is human created, it is not intelligent. And on top of that, it was never designed to be intelligent, at least not this generation of AI. It was really just designed to imitate human language. So it's actually more like a human imitation rather than artificial intelligence. So HI might be more applicable. And this picture is what ChatGPT created as an imitation of me when I wanted to illustrate it. It was quite interesting to do. But yeah, so HI is a little bit more applicable, a little bit more appropriate rather than AI. So you can think of ChatGPT's response as an imitation of a human response, just like this image is an imitation of me. So what's important to understand here is that there is no intelligence in the black box. There's no underlying knowledge. The black box is really empty. And it is merely an imitation of a human and an imitation of the intelligence. In the machine learning world, this is commonly referred to as a lack of grounding, but we'll get into that a little bit more. Okay. Natural language processing. Now that we know AI isn't intelligence, let's talk about the limits of language and computers. So I'm a librarian and a lawyer, so I love words, and I've made a career out of arguing about what they mean. Whether it's contract or a statute, any communication. Language is confusing and ambiguous, and we often rely on contextual cues and outside the actual words to help us decipher their real meaning. In English, we have words like cleave and garnish, called Janus words, that have complete opposite meanings. Where garnish can mean to take away, it can also mean to add. Cleave to separate or to bring together. How can we make computers understand that these have completely different meanings? And then additionally, language has explicit and implicit knowledge. Explicit is the knowledge that we can get from the more formalized rules, definitions, the actual words. The implicit knowledge, that's difficult or impossible to really articulate. It comes from experience, intuition, common context, common sense, understanding, and tact knowledge. None of this is what computers possess. So how can we get them to interpret these types of words and get implicit meaning by looking at it? So they do not understand the words the same way we do at all. A computer is an algorithm, and it has no connection to what words mean. Words and letters are really just symbols and representations in the computer. They're inscriptions that are decoded through software, and they take a shape in pixels, but it's really still zeros and ones. There's no substance connected to it. As humans, we can interpret their meaning and we can assign meaning to it, but the computer has no ability to do that. And this is the lack of grounding. Words to an algorithm are not grounded in any meaning or truth. They are abstract and have no implications. Natural language processing tries to find a way to give computers an understanding of language. And it's based on the premise, a word is known by the company it keeps. So by examining word patterns, algorithms learn to map words that are semantically related close to each other. And these models are trained on massive data sets, and they learn semantic relationships between the vast amounts of textual data. This allows them to go beyond simple keyword searching. This would be your natural language searching, something that you might have encountered in Google or any of your common searching techniques. So LLMs operate on the explicit representations in the text without the direct connection to the things that the representations refer to. You can think of it as if they have the map, but not necessarily the terrain. And while natural language processing isn't a new concept, it's been around since about the 1940s, it wasn't until memory and computation limits really advanced that we were able to advance our AI and make it more accessible. So let's talk about the implications of the lack of grounding that LLMs have and the lack of implicit understanding. So again, they operate on statistical patterns in text. They lack any common sense. They struggle to connect language to physical or social realities, and this leaves them vulnerable to hallucinations and generating false information. This disconnect from real-world understanding undermines AI's reliability, where nuanced, contextual aware reasoning is essential. The current version of AI is sometimes referred to as weak AI because of this. Many of the applications people have for AI would require strong AI, or AI that is actually capable of real reasoning, rather than just an imitation. Large language models. So let's talk about how that human imitation is created. Today, platforms like ChatGPT, Perplexity, Gemini, etc., they are large language models. The large in large language models is because of the large amounts of data and training that are needed for the LLM's ability to mimic natural speech. Basically, everything that it was trained on, everything that could be scraped off the internet, books, articles, Wikipedia, Reddit, YouTube. Language, it works with human languages. This is our natural language processing. And then model. It is based on statistics and probability. It is not based on meaning. It is based on numbers and prediction. So in plain language, LLMs capture patterns and statistical relationships from the training data. And then when prompted, they generate new text by predicting what word would come next. They do not work by retrieving stored text. They learn patterns and relationships only. And LLMs do not maintain their training data. However, they do maintain the patterns and relationships learned. You can think of these as a code book, and that's what's maintained and is applied to your prompt. Okay, GPTs. Hopefully I'm not going too fast. All right. Rather than building a separate model for a different task, with specialized training data, developers built a universal model based on as much text as possible across all disciplines and several languages, but primarily Western languages. This is termed pre-training, as the resulting model can be refined and applied to many subsequent tasks. It is trained and it is trained to do a prediction task. So the model should generate the next word given the context of a block of text. So it's going to generate output based on those patterns and relationships that it learned, based on that code book between the tokens by predicting the next probable word. So if you think about your prompt that you enter as N, the GPT is trying to predict N plus 1. And then it's going to take that whole prompt again and try to predict N plus 1 for that section. We'll get into it a little bit more, but just so you are beginning to understand it. So it generates outputs based on patterns and relationships between the tokens by predicting the next probable token. So let's talk about the pre-training process and what this actually goes through. So pre-training involves massive amounts of data to create a foundation for the language understanding. The key objective is to learn those generalizable patterns and relationships. Step 1 is tokenization. This is where the data, the text, is broken up into little tokens, and it's the smallest unit that an LLM can understand. It could be a word, it could be part of a word, it could be a single letter. From there, it goes to vectorization or embedding. So the model is analyzing the tokens and the sequences between them, and it's going to calculate those statistical relationships and store those as vectors on the tokens. And you could think of those vectors as longitude and latitude. And you could almost place them in a three-dimensional area. That's what we would call a vector space. It represents words and documents as points. That's what this second picture under embedding kind of symbolizes. From there, it goes through another level of contextual encoding. So this is where it assigns weights to different patterns. As it begins to predict and learn through the process, it figures out which vectors are important for determining which token comes next. and it places more weight on those, and they are considered more. This is what allows it to consider that context. From there, it goes through a prediction and learning. From this, it's kind of like doing a Mad Libs, where it'll have a blank in a sentence, and the algorithm will try to predict the word that goes in that sentence. If it gets it right, that path is reinforced and it gets more weight. And then that's something that would be seen more during its output. If the prediction is incorrect, it would decrease the strength of that pathway. So then this is the process of creating that code book for the algorithm to use. Okay, the generation process. This should look very similar to the last one. It's basically the same process, except instead of learning, it's going to be predicting. And the initial data that it's considering, that tokenization, that's your prompt. So you put your prompt in, your prompt is tokenized, it embeds your prompt with the vectors from that code book. Then it takes the context of your prompt, weighs that, and then it uses that to predict the next word. And it does that after every word. And that's kind of one of the important things to know. So if you're asking for a long output, it's predicting after every single word and redoing the entire calculation. It doesn't predict a sentence at a time. It predicts a token at a time. All right. Hallucinations. I want to talk a little bit about hallucinations because they are one of the biggest problems with current AI, aside from misuse. So let me be clear. All LLMs hallucinate. If someone tells you it does not, they are either confused, misinformed, or lying. All LLMs hallucinate currently. Maybe one day they won't, but as of today, all LLMs hallucinate. There are several causes of this, but most importantly, it's part of their programming. It is not an issue that can be fixed. Rather, platforms can attempt to mitigate it, but it is inherent in their programming. For illustration purposes, if you were to inquire about Julie Wooldridge, this is what you would get from an AI. Julie Wooldridge is an actress known for her role in National Lampoon's European Vacation and also works as a research services librarian. Well, I am the librarian. I have not been an actress. I was not in National Lampoon's European Vacation. But I am a librarian, so I had to do the research and figure out why it was assigning me this. Turns out Julie Wooldridge played Princess Diane in the National Lampoon's European Vacation. Now, it doesn't separate me, Julie Wooldridge, from this Julie Wooldridge, because it has no idea that there's two Julie Wooldridges, or that those are separate things, or that those are even people. It's just predicting the tokens. And this Julie Wooldridge has possibly more of an online presence than I do. So her information is literally coming up first. So while the output is technically correct, Julie Wooldridge is both of those things, it's not able to distinguish between them. So let's talk about why this happens. So like I said before, this is not a random error. LLM hallucinations arise from the model's architecture and training. Hallucinations are often plausible and grammatically correct, making them very difficult to detect without external verification. They reflect statistical patterns in the training data, not a connection to the truth. And they happen for several reasons. One is bad data. It's trained on what was scraped from the internet. Not all of that is true. It was trained on Reddit. I know a lot of that isn't true. So it's going to have a lot of patterns that aren't correct. And also filled with biases. Additionally, there's a knowledge boundary. There's a date that it was trained upon and not after. So anything that may have happened after, it would not have within its initial training data. Hallucinations can also happen because of misalignment between pre-training or fine-tuning. This gets a little bit more into the specifics of it, but as people specialize these general models, there can be unpredictable things that happen when they try to give it roles or convince it to go a certain way. They've often found that if you try to give it one role, the opposite of it is just as easy to get out. They call it the Luigi effect. So if any of you remember Mario, you had Mario and Luigi, and then you had Wario and Waluigi. That's kind of it. It happens with AI. And then additionally, hallucinations happen because it's a statistical inevitability. Part of the generation process uses a stochastic gradient, and basically there's an element of randomness in it. And so not every sentence that can be created has been mapped out. So in order to have that creativity in it, there is an element of randomness. And that's when you can get some of these really bizarre hallucinations that don't have any basis in fact or even basis in false training data. All right, I'm going to stop right here for a moment. That's kind of the basis about what AI is really doing. So hopefully you understand that it's really just predicting the next word, and it doesn't have any grounding to truth or real knowledge. If there's any questions right now, I'll be happy to take them.
If you could, okay, I have questions. I'll just talk because I'm not. Okay, so I'm going to repeat some of the things that I think I just learned, and you tell me how wrong I am. How does that sound?
That's
Okay.
wonderful.
There used to be a term called garbage in, garbage out.
Mhm.
And maybe people still use it. It was from coding. Anyway, so the things that, ChatGPT or LLMs, as I've just learned, or LMMs, whichever it was, LLMs, are only as good as the information they had to begin with. Okay, so, and they're also only as good as the question that we ask. So if we ask a word, because it's not reading our sentence, it's reading each individual word. So if I throw in a word that can be interpreted a couple different ways, and we as people would know, well, okay, well, when she used garnish this way, she meant garnish wages as opposed to putting an olive in a drink. And ChatGPT may not get that. And that may be one reason that we would get a bad answer. One of the things that has always amazed me is I will use ChatGPT to check my grammar. And for the most part, it's about 90% accurate, which is great, but I will copy and paste a lot of information in there. And by the time I hit enter, it already has an answer. And that to me is phenomenal / how in the world could it possibly do it? Especially with what you just told me, that it's just reading each word at a time and it's not actually understanding sentences. So that has me even more confused than what I was before you started talking. And then one more observation. You tell me how wrong I am. Is about hallucinations. Because you explained how they happen, and that all makes perfect sense to me. So it's going to have regardless of how good our question is or how well we word it, there is still going to be some garbage that comes out.
Yes.
Correct?
Yes,
All right.
100%.
Okay. So I feel a whole lot smarter than I was just a half an hour ago. Does anybody else have questions? You should be able to go ahead and unmute yourself.
Or
Or
feel
you
free
all,
to drop them in the chat if that's easier.
yes, yes, so I turned the chat off.
Oh,
I mean, I don't have mine showing up. There we go. Okay, so yeah, so the chat's turned on, or you all just, so, oh, Jan is unmuted. I'll be quiet now.
So is a word like like a digital bracket? Like an electronic digital bracket? And
It-
it sees that bracket and then it sees in a sentence and then another bracket, another bracket. And so the summation of those words or brackets is what it calls and brings to you?
yeah, the
Okay,
relationship between those brackets, basically. It doesn't
okay,
have any context to what is inside those brackets, but each token you could think of like that.
okay.
Yep. Okay. Well, I can continue on now and get to some advice about prompting uh, to help you get what you want out of it. So when I think about prompting, it's important to realize that you're talking to an algorithm and that it is taking your words and it's just trying to figure out what word comes next. And so taking that into consideration can just help you from there. Beyond that, I like to think about prompting in two parts. First is priming, and then second is prompting. Priming is really giving it the context to your prompt. This could be you telling it to take a role or maybe the audience for your whatever you're going to ask it for, the intended purpose. So for example, oftentimes I might use it to create a hypo from class. So I'd say, I am a professor in a law school. I want to create a hypo for legal research class. That would be giving it that context to help it understand the setting and help it define what it is, what the response will be. Now, it's really important when you are doing your prompting to use similar language to what you kind of want the output to be. If you're going to be wordy, it'll be wordy. If you're concise and professional in your language, it'll be more concise and professional in the response as well. All right. So general prompting advice. You want to be specific, concise, and precise. So specific, you have to be aware of ambiguous terms. Context is not always enough. This is kind of what Gail is getting to. You want to avoid those ambiguous terms. Short, that could be or duration, a length, height, up or down. That could be numerically, geographically, emotionally. These things are all going to be very confusing and lead to hallucinations a lot more. So concise. Now, every word in your prompt is used to generate the output, including any ancillary information. So if you put something that doesn't matter in there, it might end up in your final product. So keeping it tight and specific and concise is going to be a great way. Precise. Describing what you want in detail. This can often include information about what you want from the output. Or, for example, just getting the specifics of what it is that you're looking for. The example of find a print shop or find a local print shop or find a small business print shop in Durham, North Carolina. The more information you give it, the better it's going to be at isolating that decision or isolating that response. So just in general, specific, concise, and precise are my main go-tos. So now I'm going to give you just a couple of prompting techniques that I tend to use more often. So the first is chain of thought prompting, and you may have heard of this. Sometimes it's called chain of reasoning or step-by-step prompting. It's a technique that's been discovered that assists the AI in thinking through a problem in a logical or a step-by-step manner. It works because it's an emergent or latent skill, because remember, it doesn't actually reason, so it's not actually logically walking through this, but it looks like it's reasoning because it's trained on the work of people. when you instruct it to go step by step or show your work, think step by step, it forces the AI to stop making large inferences on the whole problem at once and look at the different parts of the problem. And when doing that, it can self-examine the work and you can correct mistakes, or it can correct mistakes in the inferences somewhere in the chain. So for example, if you discovered a misstep of logic, you could go back and say, and tell it that that's wrong and go through. So in effect, each prompt is kind of a link in the chain of thoughts. And that's what it's doing, step by step by step. This can tend to improve reasoning ability, especially in multi-step problems. It makes the process more transparent and interpretable, and it can potentially reduce hallucinations. But you still have to review those responses because it is not really thinking and it can still hallucinating. And so they've done studies and they found out that this type of prompting, even though it's one of the most successful types of prompting, it is very brittle and it vanishes. And in some cases, the LLMs will generate fluent and logical, inconsistent reasoning steps. And so it appears to be a structured reasoning, but it's completely a mirage. And it's just emerging from memorize or patterns. Because now it's going to give you the answer and it's going to tell you it's thinking through step by step, but it's not. So it is still just going to be your imitation of thinking it through. Got my imitation up there as well. Another one of the techniques that is most useful is one, two, or multi-shot prompting. This is where you provide one or more examples of a correct output or response within the prompt. This can be from uploading a document or simply demonstrating what you want in the response or in your prompt. The examples serve as a crash course for the LLM, allowing the model to use them as context. So it can extract the patterns from what you entered and weigh those heavier, weigh those more heavy, and predict similar to that. Now, I do want to say warning, there is a risk that LLMs will get stuck sometimes if you overfit, if you give it too many examples, it'll just start copy and pasting and it will not be actually going through it at all. So definitely something that has happened before to me when asking it to do something, especially if you're asking it to do several things at once. Okay, so those are some of my main prompting techniques. Does anybody have a question or would like to ask something specific about prompting? I can continue and we can talk through some of the costs of this imitation and some of the issues with it. Now,
Julie?
yeah. Oh,
Can I ask you a quick question before we go on to that?
yes, of course.
So if you're wanting, for instance, something that needs like formatting, like a resume, do you want to let AI just do its thing, or when you're doing the prompting for that, like I'm just trying to get a sense around, design and format.
So one thing, as far as actual like formatting text and spacing wise, it can be pretty bad at that. So you might want to more rely on it just for the words rather than the actual formatting. But in doing so, you could take a resume of somebody that looks really good and upload it, something that you like, and then have it do something similar using a one-shot prompting technique. And then you would put your information in as well. You'd have to change all the bullet points.
Right. Okay, I'm just curious if that was something design or format,
Yeah,
That it
it
could do
doesn't.
something like that.
It can, and you can get some formatting. I do warn you about using it for formatting because it's very obvious. Sometimes when people use AI for either cover letters or their resumes, because I've reviewed enough to know you'll get at least 10 that all look identical.
Ooh, okay.
So
Yeah,
as a warning.
yeah. Thank you.
Mhm.
I'm sorry, I'll stop and put in my 2 cents there because I get volunteer applications from Volunteer Match a lot, and I can tell exactly who has taken my question and then gone to AI and come back with an AI generated answer. And you can tell. And sometimes it puts in the little emojis, and that's a real tell on that. But I do want to tell the silly story that happened yesterday. I was using ChatGPT almost every day. I use it for something like today. I said, I am just having a really terrible time syncing my calendars. Tell me how to do it. And it gave me a 1, 2, 3 step on how to do it. And for the most part was very, very accurate. And then it said, after I had it proofread a document, it said, would you like me to make this into a fillable PDF? And I said, oh, sure, is how I said it out loud as I typed it in. And it returned nothing but code. It was just nothing but, and so, yeah, and you would call that hallucination because it thought it did the right thing. Anyway, so sometimes it's gold and sometimes it's not. Yes.
Yes, you never know what you're gonna get. It can be interesting. Okay, so I'll move on, and I'm just going to kind of quickly talk about some of the big costs that are concerns for people. So environmental cost. Um, there are two primary costs when we talk about AI training. We've got training costs, and then we've got the querying or the inference cost is what it's called. So the training cost, it's really driven by the data and the parameters and the compute power that was done during the training. And that's kind of a fixed cost that has already been done for the model. And then you've got the cost of the query or the inference. It's driven by the same three elements. But on average, just to give you some comparables, so about 300 ChatGPT queries, it takes about the same amount of energy as 1 hour of TV, just to kind of give you a baseline for those inference ones. And in 2024, ChatGPT 4 reportedly cost around $150 million to train. And the inference cost by the end of 2024 was projected at $2.3 billion. Just to give you an idea of the amount of money that is going into these. Now, models like DeepSeek and some of the newer ones are looking for alternative ways to train and access the data that are making successes and making it a little bit less expensive. So for example, some models like DeepSeek, they assess the prompt first and then direct it towards a smaller set of parameters or a smaller area for it to might be the best model or the best area to complete it. And ChatGPT 5, it takes when you put in your prompt, it takes it and then it decides what model it's going to send it to. And oftentimes it does not send it to that ChatGPT 5 flagship model, and it's giving you much lower and lower version models and earlier ones. So then we've got the cognitive cost. So when you use AI, it can affect how much you actually retain the information and also the diversity of ideas. While it's been shown to increase creativity some, it does decrease the diversity of ideas. And if you use it when you're learning a subject early on, it can really decrease your retention. So if you are going to use it, you should be using it after you've already done your initial learning or after you've already thought about it yourself. It shouldn't be your first go-to if it's something creative or something that you're trying to create. So then we've also got the perpetuation of bias. So the training data, it's far from representative and it contains many, many biases in it. And because of how AI functions, any biases represented in that training data will be perpetuated and amplified by AI. So you really have to think about that, especially when you are using it for different things like advertising. Just being very certain about how the wording that it's using and making sure that you're not amplifying any of those biases. Now, I also want to warn you about malicious AI. So it has been shown that it is very easy to create an LLM now that will elicit personal information from users. It's highly effective, alarmingly simple, and it's really done just by using a role in priming, like as a prompting, and then chain of thought prompting. It doesn't take much to do it at all, and it's very easy to do. So when you are interacting with what might be an AI chatbot, be very careful about the information you are putting into it. It might be trying to get that information out of you, and it may be remembering it. Also, copyright issues. So you probably heard about all the court cases going on about the training data, but you'll also have copyright issues about creating it. Who owns the copyright? Lots of different things. You don't want to upload anything to AI that you do not own the copyright of. Oftentimes, licensing agreements, different things like that, do not let you do that. So be very careful in terms of that as well. And then also, I want to touch on privacy and security. So I like something called the New York Times rule. So don't put anything in an LLM that you wouldn't be comfortable appearing in a New York Times article. You are guaranteed no privacy when you use an LLM, especially if you're using a random chatbot that you're interacting with. And then I just want to throw out there sometimes that when you could consider using AI and when you shouldn't really use AI. Oops, sorry. So if it's work that considers quantity, a lot of it, and not a high level of accuracy, that's a great time to use it. If you're the expert in an area, it can be far more effective and you'll be able to spot the hallucinations a lot easier. Summarizing large amounts of information, it can be really useful with that as long as accuracy isn't necessary. Translating or seeing a different perspective, it can be really useful to give you a perspective that you might not understand or help you learn how to talk to other people that might have a different perspective. And also work that is more ritual or long severed from its purpose. This is what I think of as cover letters and resumes and these types of things. There's a lot of it, there's a lot of boilerplate language type things. Those are good to use it for. When you shouldn't use it, when you really need to learn something. If you need to know it, you need to learn it and do it the old-fashioned way. If there's a high level of accuracy, AI is not your friend. If you don't know how AI could possibly fail you, you shouldn't use it. When effort is really the point. And then when AI is bad at the task, there are ridiculous tasks that AI can't do. Like if you ask it, how many B's are in the word blueberry? It can't count them. It doesn't understand at all. And so there are certain tasks that you should just not use AI with. So just kind of general advice. If you are going to use an AI, try to use an AI that cites its sources. I like to use Perplexity if I'm going to ask a random question. If I'm going to do writing or something like that, I'll use something more along the lines of ChatGPT. Don't upload anything you don't personally own the copyright to into ChatGPT or any AIs. Do not put personal information in it. And then do not trust the output. Remember, it is just an imitation of a human response and not a real answer. All right, that's it. So I'll stop there. And then if you have any questions, I'll be happy to answer them. And thank you all for listening.
I just learned so much. I don't even know what to say. But the thing that you just said about not uploading something you don't have the rights to. So let's say, because ChatGPT, like you said, if it's something that you really know and you just like, I want a summary of this thing. It's 20 pages long. And I know what it says. I just want you to summarize it. But if I didn't write it and it's somebody else's thing, I shouldn't upload it. I never thought about that till just now when you said that.
Yeah,
Um,
you do have to be careful with that. If it's open access, you don't have to be as concerned about it if it is open on the internet or something like that. But yeah, if you've downloaded it you needed to have password to get to it, you probably shouldn't upload it.
Okay, good to know. I have asked, because I lead a lot of book clubs, and I say, hey, you know what, you know that. And so give me some questions, and clearly, ChatGPT has not read the book because the questions, yeah, anyway. So it's not very helpful. So, I will, at this point, I will say thank you, and I'm going to stop the recording. Thank you for joining us, Julie. I'm really grateful that you're here with us because so much knowledge.